Good morning and namaskar, friends. Today we are going to start our second episode of the series Busting the Buzzword, where we'll study and understand what are different types of machine learning. Now, how many different types of machine learning depends upon what is the criteria we use to divide right machine learning. This is what we'll consider today as our criteria to divide machine learning into multiple categories. Now, what is the label data? Hopefully, you most of you know. So, if I'm, let's say, kind of have multiple images, let's say it's a cat, dog, or cat. So, as a human being, we are super intelligent. We know it's a cat, dog, and cat, right? But machine learning doesn't have eyes, so somebody has to give this image as the input and then say in output that okay, it's a cat. Maybe by saying that it's a zero, and because machine always inserts number, it's a dog, then you say one, again it's a cat, so zero. So this labeling you have to do, guys. And we have different categories of machine learning algorithm based upon how much or what percentage of data at the time of training should be labeled data. So let's, hopefully you understood the premise. So based upon that, you have multiple different types of machine learning algorithm. We'll explore them one by one. So number one, this one is machine learning, right? Is supervised learning. If you consider that, and anybody who comes first time in machine learning, what they mean by machine learning is actually supervised learning. In his mind, this is what the image is, right? And just to understand better, you can think, let's say you are going to give exam and you get a mock-up paper. So in mock-up paper, what happens is you have answers for every question in the mock paper. So you look at the question, solve it, and then go and verify your, so you can validate your answer. Now, if you understand this problem process, right, you know this is very good for learning, because any doubt and all you have, you can go and actually validate this and get it clarified. So here, it helps algo or machine learning a lot to get to extract the rules. So it's very good for learning, guys. But a lot of effort has to be done for by kind of external entity which is creating this mock paper. So in this case also, we have to get somebody hired to create this label data, and it's very tedious task. And for many years, this is one of number one reason why machine learning did not took off, because we didn't had enough number of label data. So now we understood. So here, for all the label data which actually maps input to outputs has to be given and used for the training. Now let's come to completely opposite uh, brother of this supervised learning, is called unsupervised learning. Now here learning happens based upon the patterns and grouping, right? Not because somebody have told that no, this is this and this is that. So in this case, if for example, if let's say you given a cat and dog and some more cat, right? Now here actually nobody is telling machine that is a cat or this is dog. It's not told. Then what is the, then you might ask what is, how the learning is happening? Because based upon the pattern, right, nose pattern or mouth pattern, whatever, based in the algorithm, whatever we have kind of using the algorithm, based upon that, it knows that this picture looks like similar to this picture, and maybe these two picture does not look similar to dog picture. So based upon that, actually it's kind of do the learning. Now here, let's say you can imagine this, you are going into a library, right? You're going to library. Now here, let's say is there is no labeling, but still by reading the title and maybe some little bit description, you will definitely know whether it's a science fiction or if it's a self help book, right? It is obvious because understand how do we understand the pattern, and like what can be title which will make sense for a science fiction movie book, or what should be the title for a, let's say, romantic love story. So here the learn how the learning happens is very different from what how the learning happens there. And we will learn in the future there are very famous algorithms like k-means learning, PCA, which we will use in supervised learning. One very good example of this is market segmentation. Market segmentation. So where you have a bunch of customers and you want to kind of advertise them differently, right? So it looks like your ad looks very customized. So what you do, you ask, you give unsupervised learning algorithm all this, some of the details of this, customers, and it will divide them into bunch of cluster, and then you can target them specifically, and so that no your marketing becomes more targeted and effective. Now third one, right, it's like semi supervised learning. It's like when supervised learning and unsupervised learning get married. This is the maybe product. Now here what happens is you get to you have while training you will have both kind of data, right? Where a small amount of data will be labeled, but most of the data will be unlabeled. Most of the data will be unlabeled, and you have to and then algorithm try to understand the situation. Learning is happening based upon both. For example, let's say you're solving a crossword puzzle. Now what how the supervised learning kind of you can understand is, let's say somebody doesn't give you the actual answer which you will getting in supervised learning, right? But actually it gives you some hints. So that's some hints actually is enough for you to solve this puzzle. So a good example which I like to discuss here is Google Photos, where this happens. Now you keep uploading images, right? So you keep uploading a lot of photos there. Now you have a lot of photos there, so you have a lot of data, and they are all unlabeled, because it's not that no. Whenever you upload the image, you always say that okay, this is dad, this is this person, that person. You keep uploading images, so lot of unlabeled data is there, and unsupervised learning is keep happening based upon similarities and differences between this. All the patterns and rules is kind of learned by the algorithm, and it keeps it this in its memory. Now as soon as you start tagging them, some of the images, so you might have tagged only, let's say, 3% of the images, but now combine this pattern and rules, and with all new labeling, even though small it is, now it will able to label all the images, even though you have tagged, let's say, 3 4, because now it knows that okay, if you have tagged this as your mom, and this image looks very similar to this and this, which learning already happened here, then it will tag these images also. So this is a very good use pattern of semi-supervised learning, and no, where we have a lot of unlabeled data and very small amount of labeled data, and this is used for making like a lot of fun applications. Now, third one is reinforcement. Fourth one is reinforcement learning. Now, in reinforcement learning, we don't give any data. Any data. Very surprising, right? No data. And if you have seen my earlier lecture, this reinforcement learning was somewhere. Let's say this is AI, and this is data science, and this is, let's say, machine learning, ML. So this reinforcement learning was somewhere here, where this is the we cannot consider it as a data science, but it's a definitely machine learning. Now here, just what happens is there is an agent. Okay, now there is an agent, and that agent learns not based upon data. Doesn't learn based upon data. It learns based upon trial and error. Okay, and based upon that optimizes its action for the maximum reward. Now let me understand. Let's say there is a let's say we play gully cricket, right? Gully cricket. Imagine this is a gully cricket ground, very small ground. Here is a batsman, and let's say this is the pitch. Now let's say very small in the length. So let's say there is the two wickets. Let's say bowler actually comes and does the bowling here. Now you see there is no place here, right? So and let's say after that there is somebody's house. Now we make a policy. Now what happens is, so consider this batsman as the agent, and this is the whole setup is its environment. Okay. Now agent will start with one basic policy. Okay, what is the basic policy? It has get to maximum run, right? So it will try to hit the ball. Now let's say ball is a very simple full toss, so it will try to hit straight. Now since it's a gully cricket and you have a rule that no anybody kind of puts ball here, he's out. Now what will happen next time? He optimize the policy. Okay, this is not good for me, so he will optimize the policy. And let's say next time he comes to bat and then he kind of makes sure that he doesn't hit straight. He will try to get ball here or here, and then he will get the reward. So here learning is happening based upon trial and error, and agent actually first inspects the environment. So first agent will inspect the environment, then he will take an action. Okay, he takes action is like hitting the ball. Now third is based upon the action, actually agent can get either a reward or maybe punished for the action what he did. Now when he gets a reward and both of them gets is like feedback loop, right? Feedback loop. Based upon that, if it is getting reward or punishment, based upon that it optimizes its policy, and that's how the learning is happening. So it's a very interesting field, and later on we'll understand how it actually used for let kind of very cutting edge applications. For example, self-driving car and other robotics. This is very much used. Now this is very interesting. Self-supervised learning. Now this requires some explanation, right? So it says that here actually the data actually we give for training, right, doesn't have any label, no label. Okay, but then it is not unsupervised learning. Okay, so it's not a unsupervised learning. That learning is happening without label. So the only thing is we are not giving the label. Okay, label is not given by user or whoever is training it. So basically here whole learning happens in two phases, phase 1 and then phase 2. In phase 1 the model itself creates the labeled data, and second one then is a supervised learning. So basically here first phase labeling happens, and interesting, right? So for example here this you can consider as like solving a Sudoku without getting clue from puzzle itself, right, and without getting help from somewhere else, but actually you see the puzzle and from there yourself you make sense of it, right? So no outside help, that is very important. Now let's understand how this labeling happens. Very much used in today's LLMs, right, this method. So let's say you given I love my country very much. Now this is a sentence. Now here you're not given any labeling, right? But what model will do is it will create let's say a word count is equal to 2. Now it will do is first two word I love, right? Then love my, then my country. So it will create input like this, and then here the output will be my country very. So basically if you see here the model is actually creating the label for itself. So this label is not given to the model, it is creating its own label. And so once this model is able to do this phase 1, the next phase is very simple, right? It is just becomes a supervised learning, where the first two words is let's say I love, then it has to predict that it's my, and so this is how it works, right? And this is very interesting, and it's used for training LLMs, which we'll see later. So I think we are done on this part, and I want to leave this kind of end this video with 3 quiz questions, which I would like you to not use AI, just use human intelligence, right? So first question is, which ML type learns from the label data? Please give the answer in comments. Second is this, which type power traffic signal optimization? Which is the latest trend behind language models like ChatGPT? So please try to answer and give the answer. Thank you. Thank thank you for the being audience here, and I hope you will subscribe to my channel to get more informative and fun videos like this. Thank you.